Guys, I have a question from linear algebra. The question is asking, let A and B both 4 by 4 matrices where determinant A is equal to 2, determinant B is equal to 2. Find the determinant 3A inverse BT. I'm going to do these questions one by one. Let's start from the first one. So in this case, they are asking for 3A inverse and B transpose. Let's see how we can do this. Here we go. So first of all, I'm copying this question right here. It's gonna be 6A and 3A inverse B transpose. That's what I have to find. So I can put the 3 as it is. And if you see anything like 4 by 4, it means we have to, according to this according to a rule in this question, we have to like if they give 3 by 3, I have to power by 3. If they give 4 by 4, I have to power by 4. That's how we find this answer for this one. So this is 3 to the power of 4, and they have given the determinant of A is 2. Therefore A inverse is going to be A in so determinant A inverse is going to be 1 over determinant A. Therefore this is going to be 1 over 2. I can put the 2 on the bottom straightly. Then B transpose, they are asking for B transpose, but according to the determinant rule, whatever the value transpose of B, it's going to be same. So if they ask for A transpose, it's still going to be 2. If they ask for B transpose, it's still going to be 5. Therefore I simply multiply this one by 5, and this is my final answer. You don't even have to solve it, but if you solve it, it's okay. Then next question, if A is n by n matrix where A transpose A is equal to identity, find the value of determinant A, justify your answer. So I had to prove that I had to find the answer for determinant, right? So since A transpose times A is equal to identity, I can say determinant A transpose times determinant A is going to be equal to determinant identity. Since we have this one right here, I can say what is identity. Determinant of identity is going to be just 1, because identity mean 1 0 0 0 1 0 0 0 1. Like if you multiply the diagonal, it's going to be like this, right? So first of all, we have to know identity. Identity is something like this. So if you multiply all the diagonals, it's going to be 1. Is it 4 by 4, 3 by 3, whatever it is. If you multiply, like if you find the determinant of identity, it's going to be 1, always 1. Therefore we can say determinant A transpose times determinant A is equal to 1. From this one I can say determinant A is equal to 1 over determinant A transpose, because if I bring this one to the other side, it's going to be 1 over determinant A transpose. And as we did it in the first question, whatever the transpose of A, it's going to be same as A. Therefore we can say this is 1 over determinant A, 1 over determinant A. Or you can say this is if you bring this one to other side, you don't even have to bring to the other side, because since this one is determinant A, I can bring this back, and I say determinant A square is equal to 1. Therefore determinant A is going to be square root of 1. Therefore it's going to be plus or minus 1. So this is the answer for this question. And the third question we have, let A is equal to ABC, DEF GHI, and determinant A is equal to true. Find the determinant of this one, right? So let's see how we can find the determinant of this, and they have given determinant A is equal to true. From this information I can find this. Let's see. So see, determinant A is equal to true. That's the information given. And from this equation, if you see this these three things have common coefficient, so I can like take the common factor outside. Therefore, like you may ask, isn't it should be 7 for everyone to take, or not necessary, because if you have one what do you say, one row with the same numbers, we can take it out. It's just count like per row. Like if you see 7 in 3 cases, I had to take 7 3 times. 7 outside one, 7 outside twice. So in this case, one row has 7. I had to take this 7 out. Therefore, this 2 will multiply by that 7, because we know determinant A is equal to 7 already. So this 2 will multiply by 7, and this one doesn't change anything, because G minus 3A, there's nothing we can take common. But the one thing has happened here is just swapped around. Like if you swap this one once, it will become minus, and if you swap again, it will become plus. So if you see this A, B, C has swapped to the bottom, and GHI in the middle. Therefore, what happened was ABC has swapped to the bottom, then it has to go to the top right here. Then from this one, they have swapped it again. So first it became minus, then they swapped it again. Therefore, it became plus. So the sign won't change because it's still plus. So the only thing happened was determinant we have take this 7 common, and that one multiply outside with 2. Therefore, that's the only thing happened. The final answer is 14. So therefore, determinant of this thing is equal to 14. That's my final answer. I hope you guys like this video. See you next time.